Hey everybody, this is your calculus video on monotonic functions and the first derivative test for where it's increasing and decreasing. So your objectives are to be able to solve problems involving analyzing functions from derivatives and identifying extrema. So why we're studying this is in sketching the graph of a differentiable function, it's useful to know where it increases, which is rises from left to right, and where it decreases, which is falls from left to right over an interval. This section gives a test to determine where it increases and decreases. We also show how to test the critical points of a function and to identify whether the local extreme values are present. So it's similar to what we've done before, it's just taking it one step further. As another corollary to the mean value theorem, we show that functions with positive derivatives are increasing and negative or decreasing. And if it is increasing or decreasing, it's said to be monotonic. Monotonic. This is a true statement. I think in a different video I said it was not increasing or decreasing, but it actually is. So that's actually right. But I don't test you on the vocabulary on that word. So for your corollary, suppose that the function is continuous on the closed interval and differentiable on the open interval. Then if it's greater than, it's increasing, and if it's less than, it's decreasing. And corollary 3 also says we could use less than or equal to instead of like less than. So those type inequalities. So for your first derivative test, suppose that C is a critical point and F is differentiable at every point except maybe C itself. Moving across from left to right, if f prime changes from negative to positive, it's a minimum, and positive to negative, it's a maximum. And if the sign does not change, there's no local extremum. So this is similar to your other notes, just restating it basically. And now on to the problems. So answer the following questions about the function whose derivative is f prime x and then x plus 3. The first thing you'll notice is it's asking what are the critical points. So think of setting x times x plus 3 equal to 0. Then because of that you'd have x equals 0 and x plus 3 equals 0, so you get negative 3. So that's how you get these two answers. Now, we would also need to determine whether it's increasing and decreasing. And so let's graph it. You'd say function 1 is x times x plus 3. You remember to put a dot there, because otherwise it'll give an error message. And there it is. So when we graph it, it's going to look like this. And so between negative 3 and 0, it's below the x-axis. And that's where it's decreasing. So that tells you that part, because it's below the axis. And left of negative 3 is positive, and so that's where it's increasing. So that's why it's negative infinity to negative 3. And right of 0 is increasing, or is positive, which means increasing. So basically, we're using this particular graph of the derivative to tell us where it's increasing and decreasing. So we use the graph to say where it's increasing and decreasing. And I'm going to even be a little more specific. Use the graph of f prime. That's what it gave you. And so we graphed it and we saw where it was above and below the x-axis. Now the maximum is negative 3 and the minimum is at 0. Now that looks the opposite of the f prime graph. Since if you're at negative 3, it's like down here, which you would think is the minimum, but it's talking about the function, not the f prime. So let's think a little bit more about this, because it does look like the opposite of the f prime graph, but is about the f graph. So if f prime is x times x plus 3, that means f prime is x squared plus 3x. Now, if we go up a level to f, that means you'd have to bump up to x cubed and put a 1/3 in front. And this would have to bump up to x squared and put a half in front. And then you need your 3 still. That's basically our rule for doing integrands. Oops. You basically raise a power, and then your coefficient is the fraction, 1 over whatever n is. So like, for example, if we have a 2 here, we're going to bump it up to 3, and then we need 1/3. Now let's prove it. And so if we have f is 1/3 x cubed, then f prime would be 1/3 times 3, because we bring it in front, and then we lower by power. And so that's why that's x squared. And that is actually what works. So now, when we're continuing this, this would have to always have a plus c in the back, because we don't know if there was some random constant or not. What we know is we have 1/3 x cubed, and then 3 times a half is really 3/2 x squared. Again, we don't know what that constant is, but let's graph this. For grins, I'm going to keep the blue one to be the derivative graph. And so I'm going to call this blue. So we have 1/3 x to the third plus 3/2, plus 3/2 x squared. I'm just going to assume in this example that it's 0. Now, let's see what happened. So when we do our maximum, it's going to first ask me which graph, and I'm talking about the red graph. And then I want the maximum between here and here. And that maximum is negative 2.99. Comma 4.5. Now we would just say negative 3. And then your minimum you can see is 0, 0. So when you get to these problems, and that matches what we wanted. We said maximum at negative 3 and minimum at 0. So when you get to these problems, these are for f, not f prime. So be careful with that. Okay. On this one, now you can tell this is going to give you your 7. So we set it equal to 0, and we get 7 for this one and negative 8 for that one. Now, when we graph it, graph f prime for increasing and decreasing. So we have x minus 7 squared times x plus 8. Okay, there's our graph. Now, that's not a really good window because it looks like it jumps from here to here. So you might want to make this 50 or just zoom out. I guess it's 50 wasn't enough. I'm going to zoom out. Or actually, I'm going to zoom fit. So go to 4 and then zoom fit is A. And now I can see how it looks. And when we go to the part where it's above the axis and below the axis, I need to find the 0 of the graph. And between here and here is negative 8, 0. And then this one, would be 7, 0. Okay, so where is it negative? It's decreasing left of negative 8. So that means negative infinity, negative 8. And then it's increasing right of 8. I mean negative 8. Increasing right of negative 8, which means negative 8, positive infinity. So that's that one. Now I notice it does stop here at 7, but it, for these purposes, just have it keep on going. So, in other words, it's greater than or equal to 0. Y greater than or equal to 0. So that's what we mean by above, in this case, above the x-axis. So next thing, we need to work out our next part. Okay, now let's work out our next part, and it might be easiest if we expand it. In fact, I think that is the best method based on my experience. And we are having to multiply a lot out, but you can follow along. First, I'm going to multiply everything by x. X cubed minus 14x squared plus 49x. And then I need to distribute the 8. So plus 8x squared plus 49 times 8. It's 392. Okay, so that means f prime is x cubed. I lined these up on purpose because they're like terms. So I get minus 6x squared and then plus 49x plus 392. So when we're doing our integral, that symbol is like this little thing like that. It kind of looks like an F without a line through it. So we could say the integral of f prime is really f. And okay, so here we go. We bump up a power, so we go x to the fourth. We put 1/4 in front of it. And then we keep the sign the same. And we bump this up to x cubed. And we need 1/3 here. And then we bump this up to x squared, and we put a half in front. And then on this one, we just put plus 392x. So that's what our rule is. And so f is 1/4 x to the fourth minus 2x cubed plus 49 halves x squared plus 392x. So let's graph that for the local, max, and min. So go back to the current document and say x to the fourth, no, 1/4 x to the fourth, 1/4 x to the fourth minus 2x cubed. I did that again. Minus 2x to the third plus 49 halves x squared and then plus 392x. Enter. Okay, so there we graph it. Here I'm going to do zoom fit again. Okay, and we need to find where the minimum is. By the way, it's open like that and there was no maximum. And then the min is go to minimum. It's asking which graph, and so we say the red graph. And then between here and here, okay, so it wasn't 100% right. What I realized I made my mistake on up here is the distributing part. So I did my x times everything, but I did my 8 times here, and I did my 8 times here, but this should be a negative 8 times 4 is 112. So I left out the 112 term. Minus 112x. And then I need the plus 392. And then we need to combine 49 and negative 112. We get negative 63. So that's your new function, which means this is a little bit, well, it's inaccurate, part of it. So what I should have done is had f prime is x cubed minus 6x squared minus 63x plus 392, and then do my, the integral of that, which is f, which is going to be 1/4 x to the 4th minus 6. Here we do your x cubed, and then we go 1/3, and then minus 63. Here we go x squared, and we have 1/2, and here we go 392x. So now we need to simplify that. So we get 1/4 x to the 4th minus 2x cubed minus 63 halves x squared plus 392x. So that's the one we really need to graph. So I just had a couple of terms wrong, one term wrong, it looks like. This is 63, and this is a minus. And this was still okay. 392x. Okay, so now we need to go to our menu 4A. And here it is. Our minimum is at negative 8 comma negative 3104. And so that is our minimum, and the graph continues going up, and so there's no maximum. So this is the right step, and this had one little mistake right there. That should have been 63, or actually negative 63. Okay, other than that, that was right. Okay, that looks like a good stopping point. The Math Excel may give you a different approach, which we'll look at, but I know this method works. Again, we had no maximum, and we had a minimum at -8. Okay, hope that helps.